Hi everyone. Okay, so I know that I have sent you all my videos and they were done 2 years ago. And remember when I say to you, I always change with the times. And my coding video or the probability on coding was probably a method that maybe I used before. So I want to show you a nicer, easier method. I just find this the easiest method in order to do like variations of codes when they say to you, here are numbers, find the codes. It's just an easier way of doing it. All right, so if we have let's start with the digits 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, and I want a 5-digit code. Okay, let's do, and I'm going to say to you repetitions allowed. So if repetition is allowed, then you can use those numbers as many times as you want. So the easiest option is to just say it's just a 5-digit code with repetition allowed. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So there would be 10 choices. In codes, I always use choices, not factorial. You always use choices. So there's 10 choices for the first place, 10 choices for the second, 10 for the third, 10 for the fourth, and 10 for the fifth. So that's 10 to the power of 5. If I, however, said to you, how many 5-digit codes can be made, or numbers can be made, with no repetition, then we say, now there's 10 numbers, so there's 10 choices that we've got for the first place. Now number's gone, so we've got 9 choices, 8 choices, 7 choices, and 6 choices. So you say 10 times 9 times 8 times 7 times 6, and your answer is 30240. Okay, so let's go a step further. So let's say we want 5-digit code that are even and greater than 60,000. So now look at, this is how I do it. I always look now, let's go for the even options. This is the easiest. There would be 0, 2, 4, 6, and 8 as even options. So there's 5 options. 1, 2, 3, 4, 5. 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's 5 options. And I'm going to do option at a time. So if I end with the number 0, there's one choice. That's it. One choice to end with a 0. Okay? That number's gone. Now if it starts, it has to be greater than 60,000. It can start with a 6, a 7, an 8, or 9. So there's 4 choices there. It can start with 6, 7, 8, or 9. Now 2 numbers are gone. So we've got 8 places that we can, 8 choices of numbers that we can put there, then 7, and then 6. So let's look if we ended with a 2. If we end with a 2, there's one choice of ending with a 2. There's still 4 choices of ending with a 6, 7, 8, or 9. Okay? Then there's 8 choices, 7 choices, and 6 choices. So now if we end with the even number 4, there's also one choice. There's still 4 choices, 8, 7, and 6. If we end with the number 6, there's one choice, but now 6 is gone, so we can't start with the 6. So there's only a choice of starting with 7, 8, or 9. So there's 3 choices there. Now still 2 numbers are gone, the first and the last place. So we've got 8, 7, and 6. And if we end with an 8, that's going to be the same option. There's one choice there. There's 3 choices here, 8, 7, or 6. And now we times along that line. 4 times 8 times 7 times 6, which is 1334. So this one will be 1334. It's the same, and this one will also be 1334. And then the bottom 2 will be 3 times 8 times 7 times 6 times 1, which is 1008 and 1008. So let's add those. And we land up with a total of 6018 ways or codes. All right, so let's look at another one. Okay, I want you to stop, redo this, try and do it yourself, absorb what I've done, and then let's look at another option. So have, let's say, the numbers 1, 2, 3, 4, 5, and 6. I want to make, so there's not going to be repetition, no repetition. And I want to make 4-digit codes or 4-digit arrangements that are even and greater than 3,000. So let's see, there's an even option of 2, 4, and 6. So there's 3 options. So I'll do the even options. There's lots of ways of doing these. So I can either end with a 2, a 4, or a 6. So if we're doing the 2 first, there's one choice of using the 2. Now remember, greater than 3,000 can be 3, 4, 5, or 6. So there's 4 choices. There can be 3, 4, 5, or 6. Then 2 of those numbers are gone, and we've got 4 choices and 3 choices. If I end with a 4, I've got 1 choice. But now remember, the 4 is gone, so I can only then start with a 3, 5, or 6. So there's 3 choices here. Then still left with 4 numbers and 3 numbers. And if I end with a 6, there's 1 choice. Now remember, that can't be started with, so we've only got 3 options there, or 3 choices there, and 4 and 3. And if I times those arms, it's 48, and that's 36 and 36. So the total is 120 ways. Okay, so let's look at another one. Let's say I've got the numbers 2 to 7. Okay, how many odd numbers can be formed larger than, let's just say, how many, or let's make a number, how many odd numbers can be formed larger than 4,000. Okay, so we've got the numbers 2, so how many 4-digit odd numbers can be formed larger than 4,000? Okay, so we want odd, so it can be 3, 5, or 7. So there's again 3 options. Sorry, 4 digits. So now, if it ends with a 3, we've got 1 choice. It has to be larger than 4,000, so it can be 4, 5, 6, or 7. So 4 choices. So 2 numbers are gone out of the 6. So there's 4 choices and 3 choices. So if it ended with a 5, we've also got 1 choice. But now 5's gone, so we've only got 3 choices there. We've still got 4 numbers left and 3 numbers left. And if it ended with a 7, it's the same thing. 1, the 7's gone, so we've got 3 choices, and 4 and 3. So this actually lands up being exactly the same as the sum above. So there's 120 ways. All right. So if you look at this video and you look at all the different examples I've done in the lessons, and you watch the clinic, you'll hopefully be able to get this. Let's just do one more example. Okay. So let's say you have the digits 0 to 8. How many five-digit numbers can be formed that are odd and greater than 60,000. Let's do 60,000 again. Okay, so if we've got 0, 1, 2, 3, 4, 5, 6, 7, and 8. We want odd, so it can be 1, 3, 5, or 7. So there's 4 different options. Okay, so if I ended with a 1, there's one choice. It's gone. It has to be greater than 60, so it can be a 6, 7, or 8. So there's 3 choices here. Now there are 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 2 numbers are gone. So I've got 7 numbers left, 6 numbers, and 5 numbers. If I ended with a 3, I've got one choice. I've still got a choice of 6, 7, or 8 in the beginning. Okay? And then I've got a choice of 7 numbers, 6 numbers, and 5 numbers. If I ended with a 5, I've also got a choice of 1. I've still got a choice of 3, and 7, and 6, and 5. And if I ended with a 7, it's also a choice of 1. But now there's only 2 choices there because the 7's gone, so I can only start with a 6 or 8, and there's 7, 6, and 5. So what I want you to do is once you've listened to these videos and you've gone through them, I want you to redo these sums and try and stop and pause and see if you can actually do it by yourself. But do one at a time so that you can go back and listen and try and get it right. Okay, and then this is 2 times 7 times 6 times 5 times 1, which is 420. So my total is 2310 ways or arrangements or choices. Okay, so I hope that helped. Please go through it. Please ask me questions and enjoy.